Bismillahirrahmanirrahim. My name is Sizzle Yasin, belong to Department BS Chemistry, Batch 4. Here is below my ID 2100 4067006. As today, my presentation topic name is nitric acid and the nitrous acid. So let's start our topic with nitric acid. What is nitric acid? Actually, nitric acid is HNO3. It is very important chemical as well as very interesting chemical to study. It is colorless liquid and it is very corrosive acid. But this toxic liquid has yellow or red brown fluids that can cause serious damage to your eyes and nose. The concentrated acid causes severe burns to your skin as well. This chemical can be prepared by oxidizing ammonia. We can call nitric acid by many names. As two names are shown in the slide, we can also known as spirit of nitre and aquafortis. The chemical has a wide range of uses. It can be used in paint industries, fertilizers, explosives, and many other materials. It is also used to manufacture ammonium nitrate fertilizer. So proceed to next slide. Here is the level structure of nitric acid. Now we will be discussing the level structure of nitric acid. Nitric acid, there is one hydrogen present, one nitrogen present, and 3 oxygen present. Nitric acid has the molecular formula of HNO3, which means it has one hydrogen atom forming bonds with nitrate ion. Let's understand the molecular structure of the compound, and for that, we need to look at the electronic configuration of the atoms and how many electrons they have in the outermost shell. Now we will discussing the electronic configuration of individual atoms in HNO3. Like hydrogen, its electronic configuration is 1s2. And the electronic configuration of the nitrogen is 1s2, 2s2, and 2p5. And that of oxygen is 1s2, 2s2, and 2p6. If you observe the electronic configuration of the elements, you can see hydrogen has only 1 electron, nitrogen has 5 electrons, and oxygen has 6 electrons in the outermost shell. It will help us understand how these elements share electrons to form bonds. So, in HNO3, every atom obeys the octet rule. To complete its outermost shell, to complete its octet, to complete its 8 electrons in the valence shell. So, in level structure, we place the center nitrogen atom first, then we place 2 oxygen atoms and 1 OH ion on 3 sides. As it is shown on the figure on the right side of the slide, that here is the central atom nitrogen. 1 oxygen atom is present at the right side of the nitrogen, and also hydrogen atom is present with the oxygen. And 1 oxygen atom is present at the left side of the nitrogen with a double bond, and the 1 oxygen is present at the upper side of the nitrogen with a single bond. So, 1 oxygen atom and the OH ion are connected with single bonds respectively, while the remaining oxygen atom is connected to nitrogen via double bond to follow octet rule. So, in this way, all the atoms can connected with each other to complete its octet. As nitrogen has the 5 electrons in its outermost shell, so it will form the bond with the 3 oxygen atom and gain 3 electrons from each oxygen atom to complete its octet. Here, in this way, the nitrogen atom attains a stable configuration of 8 electrons. It forms a double and a single bond with 2 oxygen atoms, while a single bond with an OH ion. Here it will clearly shown in the figure that how nitrogen atom can bond with oxygen atom and how oxygen atom bond with one hydrogen atom. Here only oxygen has lone pairs around it. Lone pairs can also shown in this figure. The one oxygen atom that is present at the left side of the nitrogen has two electron pair, and the one that is present at the upper side of the nitrogen has three electron pair, and the one that is present at the right side of the oxygen atom and the also attached with hydrogen has two electron pair. It is clearly shown in this figure how all the atoms can bond with each other and how many lone pairs are present on each atom. So the oxygen atom in the OH chain has one single bond with hydrogen, one single bond with nitrogen, and two lone pairs. So proceed to next, that is the molecular geometry of nitric acid. If we look at the shape of one thing that I can tell you, that molecular geometry of the nitric acid can be determined by the two theories. It is also discussed on the slide, but I will tell you that it can be the geometry can be determined by the two theories, by the Lewis structure as well as by the Vesper theory. What is Vesper theory? Valence shell electron valence shell electron pair repulsion theory. So now we will discuss the bond theory. If we look at the shape of HNO3 molecule, it has a trigonal planar shape. The molecular geometry of any molecule is determined by two things, that is the Lewis structure and the Vesper. If we look at the Lewis molecular structure of HNO3, we can see hydrogen has 1, nitrogen has 5, but oxygen atom has 6 valence electrons. During the bonding process, the nitrogen atom connects with one oxygen atom through a single bond. It forms two single bonds with another oxygen atom and the OH atom. The oxygen atom form lone pairs. The first oxygen atom has 2, while the second one has 3. The oxygen atom in the OH chain has 2 lone pairs. The Lewis structure, it will telling about us how I will tell you early that how oxygen atom connects with nitrogen and how many lone pairs are present with it, and how hydrogen connects with oxygen and how many lone pairs are present in it. The Vesper theory states the pair of electrons or the bonds tend to stay at the maximum distance as they repulse each other. It gives the molecules a stable shape. Apart from this, the covalent bonds and the lone pairs determine the structure of the molecule. The electron pairs participating in a bond repulses each other. The repulsive force is the highest between two lone pairs. It is less in the case of lone pair and the bond pair, and the least between bond pairs. From this, we are concluding that the repulsive forces is highest among the lone pair and the lone pair. Then it is low in the lone pair and the bond pair, and then it is highly less between the bond pair and the bond pair. To understand the molecular geometry of HNO3, we have to look at the Vesper theory. The central atom is nitrogen. This is shown in the figure below. Here, central atom is nitrogen. That is shown by the blue color, the blue ball. Here it is nitrogen, and the 3 red balls that is shown, it is the atom of the oxygen, and in the white color, it is hydrogen attached with one oxygen atom. As the electron pairs repulse each other with maximum force, so the atoms around them stay at the maximum distance possible so that the force of repulsion is minimal. Another thing that helps us find the molecular structure is the steric number. We can also find the molecular structure by the steric number. We can find the number by adding the lone pairs with atoms that are involved in the bonds. In HNO3, nitrogen forms bonds with three oxygen atoms and there is no lone pair on nitrogen. So the acid of the nitrogen atom in HNO3 is 3. On the other hand, the oxygen atom bonded to hydrogen has an SN of 4 because of two bond pairs as well as two lone pairs. If we refer to the Vesper geometry table, we can find the compounds with the central atom has steric number SN3 and the lone pair has shape of trigonal plane. The HNO3 molecule exhibit polarity due to the lone pair and symmetrical shape of the molecule. Here are HNO3 topic ended. Now we will discussing the nitrous acid, that is HNO2. HNO2 or the nitrous acid comes under the category of monoprotic acids, acids that donate on photon during dissociation. It is a weak acid as compared to HNO3 and exists only in solution form in the form of nitrite salts. Nitrite salts are NO2. Nitrous acid has a relatively lower percentage of oxygen than nitric acid. In nitric acid, 3 oxygen are present, but in nitrous acid, 2 oxygen are present. Quite unstable in nature, it was discovered by Steele. It has a pungent odor and appears as a pale blue solution. Nitrous acid is prepared by acidifying sodium nitrite and minoic acid. This is usually done at ice temperature and the product HNO2 is produced in the reaction mixture itself. Here is the reaction below. When dinitrogen trioxide mixing with water, it will give a nitrous acid. So proceed to next slide. Here we're discussing the structure of nitrous acid. Making a level structure is the first almost crucial step for identifying various properties related to the bonding of the molecule. Hence, whenever bonding is mentioned beside a molecule or a compound, your mind should immediately jump to the level structure of the given compound. Now, before we proceed to make the level structure for HNO2, there are a few things you need to know. The number of valence electrons of an atom is denoted by the level structure. Valence electrons of a particular group can be determined by looking at the number written on top of their column in a periodic table. The valence electrons are shown in the form of dots around the atom. These electrons are arranged in such a way that each atom completes its octet. This basically means each atom should have 8 electrons around it so that it can achieve its stability. Here shows the structure of HNO2 in which 2 oxygen atom present and 1 hydrogen atom present. 1 oxygen atom is present at connected with nitrogen with a double bond at the upper side of the nitrogen, and the 1 oxygen atom is present at the right side of the nitrogen with a single bond, and also hydrogen atom is connected with the oxygen atom with a single bond. Only hydrogen and helium are exceptions as they follow the duplet rule. For example, 2 electrons in the outermost shell. In HNO2, we know nitrogen is central atom. It's bonded to 2 oxygen atoms and has a lone pair. Thus, the total hydrogen is 2 plus 1 is equals to 3, making it sp2 hybridized. Here is the molecular geometry of HNO2. The next important step is to determine the molecular geometry of HNO2, same like as HNO3 nitric acid. It gives us the shape and the bond angles between these atoms. The molecular geometry of HNO2 is band, a band-shaped molecule. The bond angles bonds are close to 120 degrees. The bond angle that is formed that is 120 degrees. Here also show the molecular structure of the HNO2. This can be determined by using the AX notation, where A represents the central atom, which is nitrogen. In this case, so A is equals to 1. Next, we look at the X, which represents the number of atoms bonded to the central atom. Here is X is the oxygen atom and the hydrogen atom, and A represents the nitrogen atom. So X equals to 2 oxygen atom bonded to nitrogen. Now nitrogen here represents the non-bonding electrons, lone pairs on the central atom. Here n is equals to 1. As there is the pair of one lone pair on nitrogen atom, thus we get the notation as AX2N. So here is the structure. Here we can see that nitrogen has the one lone pair and it is bonded to two oxygen atom, bonded with the oxygen atom. With double bond with one oxygen and the single bond with other oxygen atom that is connected with the hydrogen atom also, and both has oxygen atom has two lone pair on it. Here our presentation ended. So here our nitric acid and the nitrous acid discussion ended. So please who can see this video, please subscribe this channel also and also like this video. Thank you so much.